All right, in this next example, we're going to be solving this right triangle. Whenever you hear that phrase, solving a right triangle, basically, you just need to find out what are all of the missing side lengths and what are all of the missing angles, okay? So let's take a look at this right triangle. Solve the right triangle. Round decimal answers to the nearest tenth. Okay, let's take a quick look at what's missing. We do not know what the side length is of C, and it looks like we have two angles here that we don't know are the values of, okay? So that's what we're going to solve out here. So I'm just going to put that off to the side. We do not know what C is, so we have to find C. We also have to find the measure of angle B, and we also have to find out what the measure of angle A is. There's many ways that we could tackle this kind of problem, but let's start off simple. Let's go ahead and maybe solve for this missing side length over here. What I'm noticing right away is, well, I have a 2, I have a 3, and then we have an unknown hypotenuse. What do you think of when that comes to mind? Probably the Pythagorean theorem. What is the Pythagorean theorem again? Basically, these two side lengths, a squared plus b squared, is going to equal the squared length of c. Okay? And now let's go ahead and just substitute these values here. We already know what a squared and b squared are. I'm just going to substitute a with 2, and I'm going to substitute b with 3. And that's going to give us c squared. And now let's just go ahead and solve this. Equals c squared, 13 equals c squared. And then if I wanted to isolate the variable c, I'm going to square root both sides. So now what do we have? The length of c is going to be square root of 13. And I'm going to leave this as a radical, okay? When it comes to solving these kinds of problems moving forward, it's preferred that you leave it as a radical and you try to reduce or try to simplify the radical also, because when you're rounding things off right away, it can cause a little bit of a discrepancy. So like if you had like 18.09934 or something, obviously that's going to be different from like 18.1 or 18.0993, right? So you just want to keep things as they are for the time being, okay, until it's appropriate to use it in another sense. But that's besides the point, okay? All right, cool. So we already found out what C is. Now let's go ahead and find out any of these angle measurements over here. Let's start off with B. Let's find out what is the measure of angle B. Okay, so if we already have our side lengths and we are missing angle measurements, maybe we use something that we just recently learned to find out what an angle measurement is. And that's where these inverse trigonometric ratios are going to come in, okay? So I can use either sine, cosine, or tangent. For the purpose of this example, let's go ahead and use my favorite one, tan. So let's go ahead and just set up a ratio to prove something. So the tangent of, in this case, our theta is going to be b. So the tangent of b is going to be what ratio? Remember, according to SOHCAHTOA? No, really? That was fast. According to SOHCAHTOA, I am going to get our opposite side over our adjacent. That is the ratio here. So our opposite side is going to be 2, or angle B. So 2 over 3. Okay, and remember, according to our inverse tangent, if tan of A equals x, then the inverse of tan x equals the measure of angle A. That's just basically to say, instead of it being this, the tangent, but now the inverse tangent of, now we're just going to switch it around, okay? So the inverse tangent of 2/3 is going to give us the measurement of angle B. And now let's just go ahead and pop this into a calculator to see what we get. So, booey. So the inverse tangent of 2/3 is going to give us a measure of angle B, which is 33.69. Nice. But remember, to the nearest tenth. So to the nearest tenth here, so since it's 0.69, we're going to round it up to 33.7 degrees. Nice. So we're 2/3 of the way done. Now all we have to do is find out the measure of angle A, and we're good to go. So the measure of angle A is what we need to find now. We could do this one of two ways. I'm thinking of something very simple, but I'm going to show you both ways anyway. Remember that the internal angles of any triangle always equals 180 degrees. In this case, that's just to say that angle A, I'll do a different color. Angle A plus angle B plus angle C has to equal 180 degrees. Thank goodness we already know two of these three, and all we have to do is just solve for the other missing angle. Okay, so we don't know what angle A is, but we do know that the measure of angle B is 33.7 degrees. The measure of angle C clearly is 90 degrees, and that has to equal 180 degrees. So let's go ahead and simplify this. 33.7 plus 90 is going to give us 123.7 degrees, going to equal 180 degrees. And then to solve for angle A, we're going to use inverse operations, subtract 123.7 on both sides. So angle A, or rather the measure of angle A, is going to equal 180 minus 123.7. If you can't do that in your head, that's okay. I believe this is going to be 56.3 degrees. And let's just check our work. 180, or actually 33.7 plus 90 is 123.7, and 180 minus 123.7 is 56.3. And there you have it. We have completed solving this right triangle. But let's just say, for example, we totally forgot about the triangle sum theorem, right? And we wanted to use an inverse tangent ratio instead. So let's take a look at that, okay? If I wanted to find the measurement of angle A right over here, let's try using an inverse tangent ratio. Let's not use tan this time. Let's try something like the sine of something. Okay, so let's write it out first. The sine, I'm going to use this purple again. The sine of A equals, so what is it going to be? It is our, totally blinked out. Sine, opposite over hypotenuse. Okay, so our opposite of angle A is 3. And then what is our hypotenuse? It is root 13. And that's why it's important to do the root 13. Okay. Yes, we could simplify this, but I'm just going to leave it like this because we're going to pop it into a calculator anyway. So now let's use the inverse sine. So the inverse sine of, so remember, we're going to flip it around. The inverse sine of 3 over root 13 is going to give us the measure of angle A. Let's see if it's also going to be 56.3. And now let's find out. So the inverse sine of 3 over the square root of 13, please be 56.3. 56.3. That is insane. Is it really though? No, it's just math. Okay, and that's how you can solve a right triangle. Okay, thanks. That's it. Bye.